if a polynomial function is written in factored form, like this one, x squared times x minus 1 times x minus 1 times x plus 2 times x plus 3 times x plus 3 times x plus 3, I can immediately find my x-intercepts, or the zeros, or the solutions to this polynomial equation. My x-intercepts are going to be at 0, positive 1, negative 2, negative 3, negative 3, negative 3. Another way that I could have written this polynomial function in factored form is f of x equals x squared times x minus 1 squared times x plus 2 times x plus 3 cubed. We call the power of each factor the multiplicity of the factor. The multiplicity of a factor is the power of the factor, or you can think of it as the number of times that the factor is repeated. One thing that we should know from our time that we spent with quadratic functions is that if I have a 0 for a quadratic function, it can either touch the x-axis or it can cross the x-axis. And we'll be able to determine which happens for each of these zeros based on the multiplicity of the polynomial function. If the multiplicity is even, our 0, or our x-intercept, we will touch. If our multiplicity is odd, we are going to end up crossing the x-axis. So this one we touch the x-axis. If their multiplicity is odd, we are going to cross the x-axis. So using this information, we can start sketching the graphs for our function. So let's analyze this polynomial function and use all of the previous information that we have to come up with a rough sketch of the graph of the function. So first thing I'm going to do is I'm going to identify where I have zeros. I have a 0 at 0. I have a 0 at 1. I have a 0 at negative 2. I have a 0 at negative 3. I can also identify the y-intercept easily by putting a 0 in for all of these x's. Well, if I put a 0 in for this x, a 0 times anything is 0. So I know I have a, oops, I forgot that 0. I have a y-intercept at 0. Now let's figure out what the degree of this polynomial is. Well, it's 2 plus 2, which is 4, plus 1 is 5, plus 3 is 8. So we know n is equal to 8. So we know, and we know our leading coefficient is positive because I have a 1 times 1 times 1 times 1 all the way through here, so that we know it's going to be an even function. So we know the end behavior of the even function means as x approaches negative infinity, f of x is going to go to positive infinity. Same as x approaches positive infinity, f of x is going to approach positive infinity. So I know my graph is going to do this at the two ends. And now I'm just going to come up with a rough sketch at the x equals negative 3. And here's my x, here's my y. When x equals negative 3, it's odd multiplicity. If it's an odd multiplicity, it's going to cross the x-axis at negative 3. When x equals negative 2, it's an odd multiplicity, so I know it's going to cross the x-axis. When x equals 0, it's an even multiplicity, so it's going to touch the x-axis. And when x equals 1, it's an even multiplicity, so it's going to touch the x-axis. And I have my end behavior. one thing I want to point out is we do not have enough information right now to figure out exactly what's happening in between these regions. If you go to take calculus, you'll be able to analyze to find out where these local maximums are, where this local minimum is. For the purposes of the college algebra class, we want just the basic shape of the graph. We know what the end behavior is. We know whether it's crossing or touching our x-intercepts. So that will give us enough information to give a rough sketch of the graph. So let's count our number of turning points. 1, 2, 3, 4, 5. Well, we know the maximum number of turning points is 7. So 5 is less than 7. So it does agree with all of the information that we know. So if you're given a polynomial that is in general form, which is something x to a power plus something x to the next power, descending and stuff like that, if you write it in factored form, which is where the rational roots theorem, Descartes' rule of signs, using the quadratic formula once you get something in quadratic terms, solving it by square roots once it's in a quadratic term, you put it in this form, you are now going to be able to give a rough sketch of the function. The second place where this comes into play is if you are given the sketch of a function, can you come up with the equation for the function? So what I'm going to do is I'm going to give you the sketch for a function. I'm going to give you one point that is not a 0. And we're going to use this information in order to write the equation for the function. So this is x. This is y. 1, 2, 3, 4. 1, 2, 3, 4. So these are 3 points I know. I know my polynomial has to have an odd power because it goes from negative infinity to positive infinity, and that's an odd power. So what I'm going to do is I'm going to write my function using the information I know about the zeros. Well, my polynomial function is some coefficient times my zeros raised to a power. Well, I have a 0 at 2. So the factor would be x minus 2. It touches the graph, so it has to be even. Let's come back over here. I have a factor of, I have a 0 at negative 1, so I have a factor at x plus 1. It's odd because it crosses. And this is one answer. Well, I have this point right here. Well, if I substitute a 0 in for x, I can solve for a. Other thing I want to tell you is this x minus 2 could be to the 4th power. It can be the 6th power. It can be the 8th power. There are an infinite number of polynomial functions that go through these 3 points. The directions for your homework are going to be write the polynomial function of least degree. Well, the least even number is squared. And the least even one here would be to the 1st power. So we're going to start there. Now we're going to use 0, 2 to actually find our a. Well, when x is 0, f of x is 2. 0 minus 2 is negative 2. 0 plus 1 is 1. So I get 2 equals negative 2 squared is 4. 4 times 1 is 1. So I get 2 is 4a. Solve for a, I get a is 2/4 or 1/2. And to write this function as the lowest degree polynomial, it would be 1/2 x minus 2 quantity squared times x plus 1. So if you are given the graph with your zeros and at least one point that is not a 0, you can write it in factored form. Or if you're given it in factored form, you can approximate the sketch of a graph.